Again, good afternoon, everyone, and thank you for attending our technical workshop. First of all, I would like to also thank everyone for attending the lecture last week. And this is a continuation of the lecture last week. This is the workshop component, no? So last week you were able to discuss object segmentation network. I think that's the first lecture that tackled object segmentation network or instant segmentation networks in our lab. For this afternoon, we are going to discuss the workshop component, which basically would teach you how to implement object segmentation networks. So the title of the presentation is Development and Evaluation of Object Segmentation Networks. This is the abstract of the presentation. This workshop offers participants a comprehensive introduction to object segmentation, which is an essential technique in computer vision for precisely identifying and delineating objects within images. Designed for beginners to intermediate learners, the session walks through the end-to-end workflow of developing and evaluating object segmentation models. Attendees will be guided through the practical steps of setting up and training object segmentation models, followed by evaluation procedures using standard metrics. We are going to conclude with the analysis of model performance through quantitative metrics, helping participants interpret models and results and refine their models effectively. So by the end of the workshop, participants will have built a functional object segmentation pipeline and gain the confidence to apply these techniques to their own projects. Just so you have an idea, the workshop will cover introduction to object segmentation, how do we prepare the environment, preparation for the dataset, a review of the things that were discussed last time, setting up the models, training your models, evaluating the models, and the metrics and results. So we have also provided in the invite what are the prerequisite knowledge, the dependencies, and installation that you would need to have, no, just in case you want to run the notebook for yourselves. We'll provide you after the workshop with the link to the workshop materials. So let me introduce to you our speaker for this afternoon. Our speaker is Aaron Gabriel Dichoso, currently a fourth-year computer science student at De La Salle University under the BSMSCS Honors Program. As a member of CIVI, his laboratory experiments focus on camouflage crop detection with an interest in pursuing the improvement of network architectures for his thesis research in the pursuit of accelerating agricultural infrastructure in the country. So without further ado, I am giving the floor to Aaron. Aaron, you may start your presentation.
Hello, everyone. Thank you, Sir Aaron, for the wonderful introduction. So, without further ado, let us start now with our workshop for object segmentation. So, keep in mind that all of these files that I will be working with right now, they will all be sent after the workshop, anyways. So, let us just be reminded again as to what object segmentation is. Okay, so unlike object detection and image classification, object segmentation aims to capture the specific contours of an object and multiple objects in its given an image. So that is what we are actually going to work on today. And by the end of the lecture, we will have made our own semantic segmentation network. If we were to remember what semantic segmentation is, it is when the model assigns specific class labels to each pixel in an image. So that is our output for today, and we are going to be using FCN as discussed before in our lecture, because that is one of our foundational networks for object segmentation. Okay, so let us start here with our workshop file. So before anything else, I would have expected you guys to download these things. So these are just the libraries that we are going to use for today. And another way that we can actually download it is some repositories that you will see online. They would have this thing called the requirements.txt file. So in this requirements.txt, it would have written down all of the different requirements that you would need to run like the repository that you have. So I've also included it in our workshop files. So what we can do is to just type down pip install /r requirements.txt. So now by doing this, if for example you're trying out a new architecture from um another organization or repository, they would usually have this repository requirements.txt so that you could just like set up your environment the same way as like what they used in their own setup. So in this lecture, the important things to take note of is PyTorch and Torch Vision. So PyTorch is like this extensive Python library containing like different tools that you would need in order to create just different neural networks and different models all in all. And Torch Vision specifically is like containing all of the libraries specific to computer vision. Here, we are importing our ResNet 50 FCN version. So FCN, yeah, it's our semantic segmentation network. And we are going to be modifying this for the purposes of our workshop. So let's start now with like the configurations that I've made to this workshop file. So we are going to be using the MS Coco dataset. So MS Coco, this is created by Microsoft, and it contains all in all like 91 classes and of objects and like over 300,000 images. So of course that is not feasible for us during this lecture. So what I've done is I've actually performed sampling on that dataset to only isolate just 12 objects that our model will train on and to detect and to actually segment in our images. Okay, so those are the classes that I have prepared here. So it can detect dogs, cats, persons, chairs, mouse, computer mouse, remotes, keyboards, cell phones, cups, forks, knives, spoons. And what's interesting here is person. So later on, we'll actually run this using our webcam so that we can like, try it out. And how did I perform this like sampling? As we will be able to see here, I have a file here called sample.py. So this is just also a bit of exploration when you do eventually get the repository. So this is what I use to actually sample the dataset here. So this is the source dataset. So this is all of the MS scope. Oh, sorry. Uh, sorry, the screen sharing was paused. So I have here the source dataset here, which is the 2017 MS Coco validation set. So this is too big for our purposes. So what I do is I sampled it using this script that I made. So what it does, it's going to sample it into 3 types of data sets that we're going to use: a training, a testing, and a validation. I'll explain what each of those does. So it just splits it into 3 different sets. And what it does here, it uses this library called PyCoco tools. This is a specific library that's used for the MS Coco dataset. So you can use this if you're also working on MS Coco dataset. Just makes it a whole lot easier. And using this COCO library, I'm going to get all of the category IDs. So just all of the different classes that I want to take here. And after that, I'm going to load in all of the annotations. So the annotations just refer to like the IDs that each of the segment has. And aside from that, I'm just going to take all of the images with a category that only exists with the type of classes that I have. So that's all that I'm doing here. I'm just like isolating all of the images that I want to use that has those specific classes only. And then after that, I am just going to sample that until I get that many images that I need for all of the training, validation, and testing data sets. And then I just randomly shuffle it and then I split it across those data sets. And what I end up with here is this, the COCO sample. So this one is the data set we're actually going to use, and it consists of only images that have chairs here. Most of them, oh, they also have knives. And I think here it's looking at the remote or the TV, I think. So, and here it's also looking at the different people around. And it also generates this test.json file. This is actually the annotations, because how MS COCO is structured is that it has an annotations file here. So that is what's actually being read in this line. And the annotations file only simply says what position the segments are located at, and like just general information that you need to know about the image in the dataset. So all in all, that's how I sampled the dataset here. And I'm only using like 275 images for the training, 28 images for validation, and 45 images for testing. And these are just what I said, the classes that I wanted to take. If you guys want to see the different classes as well, I also have here for this classes.py. This just lists down all of the different classes that MS COCO already has. This, oh, sorry, I just need to, there. So it shows us if you also just want to like train your own data set as well using a subset of MS COCO, you can do that as well using this file that I provided. Okay. So now let's actually move into the workshop and how I trained this model. So important hyperparameters to keep in mind whenever you're training any dataset are usually these four. Okay. So first, the batch size. The batch size refers to how many images you're passing into the model at the time for every iteration. So let's be reminded again of like the general training process for any neural network, right? You take your images, you feed it into the neural network, and then using like the difference between its predictions and then the ground truth or the actual labels, it's going to have this loss value that is going to be used to adjust all of the different parameters inside of the model, right? So batch size refers to how many images you're passing at the time. So instead of passing one image at a time, what we're doing is we're passing 4 images at a time. So that just helps out a bit. Usually it improves, sometimes it improves accuracy, sometimes it improves performance, sometimes it improves speed. So this is just something that you can like play around with and find what you want to use. The number of classes here. So what I have here is 12 objects and I added a +1, so 13 not null. because when you're doing object segmentation, you always have to keep in mind that there's one extra class being used for background. So that's just something to keep in mind for object segmentation. Number of epochs. So an epoch is just like one cycle of training. So I'm doing 45 cycles here. You do not need to actually do that. It depends on you just how much you want to train your model. Usually 45. That's what I would do. But depending on your system, you could do like 20 or 10 or whatever. Just like keep in mind, more epochs usually generally means more increased performance up to a certain point. And finally, learning rate. This refers to, right, when you are training your model, it has like this loss value again, right? So we're talking at the loss value again, and then we are adjusting the weights accordingly to that loss value. We do not want to adjust the weights too widely, because what that would do is you would sometimes like overshoot or like over adjust your model configuration, and then it wouldn't like actually improve over time if you like over adjust over and over again. So that's why we have a learning rate that specifies how softly or how largely you want to adjust the weights of your model according to the loss, so that it's like a slow and steady learning experience, right, for the model, instead of just widely over adjusting, which may result in like actually your model not learning anything. Okay, so I'll just run these, and I'll run all the way up to here. Actually, I'll just run all of them because the training is going to take a lot of time. Okay, after all of these configurations, I am now just going to get the files that I need in order to import my dataset into the notebook. So this is just the directories that I have here for Coco sample, the training, testing, and validation, and their specific, their corresponding annotations files. Okay. So far, is what I have discussed clear for everyone so far? Or are there any clarifications? Can I have like, I don't know, some reactions or comments? Okay, so far it seems everyone's following along. Okay, now let's move on to actually reporting the data set. So what I do here is I create what's called a data loader. So a data loader is used here. It's like given by the PyTorch, and what it does is it just handles how to give your images and your ground truths to the model. So this is going to be handling all of that, because, right, you do not want to use the images right away. You might have some like reprocessing to perform on those images first before actually giving it to the model. So the dataset loader handles all of that and streamlines the process into just one class itself. So how do we actually define the data loader? So you have to keep in mind these three functions that need to be overridden. First off, you have to inherit the class from here, torch that utils the data set. Then you have to override the init function, the get item function, and the length function. So this init function, this is our class constructor. Okay. And here I just defined all the things that I'm going to use for my data loader. So I'm keeping track of the keys that I want to take. the different categories that is located in the data set, the target size. So before I actually feed it into the model, I want to like ensure that all of the images are the same size. And in here now, I also have this special function here, cat ID to index. So this is a dictionary that I use to just remap all of the different IDs in MS Coco. So if we were to go back to this class, the PY, if I were to go back here, terminal. So we would see like there are a lot of different classes in MS Coco, and their actual IDs are different from the IDs that I actually want to use. So person is ID number 1. Then if we look here, cat is like ID number 17 or 18, something like that. So I have a different ID label from that is being used from MS Coco. So I need to remap all of those IDs from like 17 or like this, see, right here. So these are like the different IDs that MS Coco actually has. And I need to remap them to just 1, 2, 3, 4, 5. Okay. So that is what this dictionary is doing, as well as these class names. So I'm just remapping all of those information again for my purposes because I sampled MS Coco. And here, I also added a background label for ID number 0. This one, the get item method, this is what's going to be used by your data loader in order to actually retrieve an image from the dataset. So how it is implemented here is that it has an index, and this index refers to the specific one specific image in your dataset. And with that image, you have to specify all of the transformations that you're going to make before actually returning the image. So in here, I just loaded my image up, and then I got its annotations, and then I obtained its image information. After that, I actually load the image from the file itself. So from this data, Coco sample dataset right here, I just load it into the notebook, and then I perform here my image transformations. So just this transformation just resizes it so that it's in my target size of 480 by 640. Okay. And then this image tensor here, this just converts my image to a tensor, which is what it's being used in the convolutional neural network. And not only that, I also do my transformations for the segmentation mask. Because, right, this get item, this is also going to return your image and the ground truth that this corresponds to. So for the segmentation mask, what I do is I define a new NP0s array. So after that, I remap all of the original labels in MS Coco since, right, it has like a different ID scheme in here. So I just remap all of those to my corresponding IDs in this sample set, a sample data set. So this is what just all that it is doing. And finally, I just also convert it again to a tensor because that is what the CNN uses. And then I return all of those values. And finally here, def len This is just you just have to return just the length of your data set here. Okay, so that is how the data loader is implemented. And to actually use it, I just have to run here Coco segmentation. I just have to instantiate it with the image directory that I want in the annotations file. So here I have three data sets as explained. The training data set, the testing, and the validation. And also I have your data loader. So this is what actually handles the loading. We just needed to like convert it into the correct class. And here we have like the data loaders for each data set. So what does each data set, what is each data set doing? So the training data set, that is what you're actually using to train the neural network or the FCN, okay? The validation data set, that is what I am using here for validation. So after every epoch, I uh, I run the model on this validation data set just to observe the performance of it after that epoch. And then using that information, I would determine whether or not there has been like an increase in performance before and after the epoch. And I would save the best model throughout the epochs during that training process. And finally here, the test data set is actually what we're going to use for evaluating our data set. Sorry, evaluating our model. Okay. And here, this section, this is just, what I'm just doing here is taking the existing FCN model in PyTorch Vision and just remapping it to use the number of classes that I have given. So just 13 classes instead. And this one, model.to device, this actually uses CUDA. So yeah, if available. So for those who do not know, CUDA is this library given by NVIDIA. So if you have an NVIDIA GPU, you can actually load your training process and your models and your images into your GPUs instead of your CPUs. So people usually do this because GPUs, their computer architecture is much more, it's much more aligned to the training process of a neural network, wherein neural networks, they perform lots of repetitive multiplications over and over and over again. And that can actually be optimized and perform better when you put it into a GPU. So this just loads it in to the GPU if you have. However, this notebook, it should still work even if you don't have a CUDA compatible GPU. It's just going to use your CPU and may take longer than usual than what I have here. Okay, aside from that, I also have 3 modules here that I'm going to use throughout the training process. Here I have a criterion. This just specifies how I'm going to compute the loss function. So good, Torch already has cross entropy loss, which is what is being usually used for object segmentation, because you are looking for categorical. Your object segmentation is like a classification problem. Hence, you're going to have the categorical labels. That's why I use cross entropy loss. Aside from that, optimizer, this just specifies how the weights are optimized. So a really standard one is add-up optimizer, given also by PyTorch. And in here, I also have a learning rate scheduler. So what this does is that it actually decreases the learning rate of our training process over time. So why do I want to decrease the learning rate over time? Well, if we were to go back to that analogy of you do not want to over adjust your trading process. If your model has already trained with the same learning rate over many epochs, then your model will also slowly learn more and more and more about your data set, about your problem, right? So over time, over epochs, you just want to um, make smaller and smaller adjustments just to refine the performance, not necessarily learn um, big things about the problem. You just want to like refine it over time. That's why usually you have this learning rate scheduler, which like decreases the learning rate or how fine the just makes your adjustments even finer over epochs. Okay, and now we actually get into training. So far, is everything clear for everyone? You have a thumbs up or a heart react or anything? Thank you guys so much. Okay, now here comes the training process. Okay. The general flow is as follows, as seen here. We just set the model to training mode. This is just being handled by PyTorch because there are like some specific modules in your model that you want to be enabled during training and you want to be disabled during testing and actually using the model. So for each epoch, you have to do the following. You load the images into the device. You zero out the existing gradients. So this means zeroing out is because after every epoch, there may be some gradients left in your model. And you just want to like clear those just for a fresh start in the training process again after an epoch. And then after that, you perform a forward pass. Forward pass just means passing all of the images to the model. Compute the prediction performances loss using our criterion here. And you perform a backward pass and update your weights. So that is our optimizer's job. And finally, you save the model checkpoint. So this model checkpoint, after every epoch, I save it just so whenever I would want to like run the model again, I could like improve upon that specific epoch instead of just restarting my training process. Okay. Let's actually let's actually backtrack and look a bit here at our FCN architecture. Okay. So as discussed last week, this is the FCN architecture here. So I just want to like point out the different modules that we actually determined last week during the FCN architecture. So in here, this was the first layer that we saw, the first convolutional block. And each of these are actually convolutional blocks as well. So what that is doing is that it is like decreasing the image resolution while increasing like the number of channels. So just giving more and more context and learning for our model. And then finally, I think here, there we go, the FCN head. This is the actual decoder. Oh no, this is the decoder right here. So after decreasing like the resolution of our model of our image and increasing the number of channels, we then decode that information again by upsampling it again. That's why we see here it went from 512 to 58. So from decreasing the resolution, it is now then increasing the resolution again here. Until finally it would give back the classifier, which just performs the actual classification for each pixel. Okay, so that is how you could actually like interpret these specific um, layers and what it is doing. It is corresponding to like the figures that we've shown last week. Okay, so now let's actually look at the code for training and just point out like the corresponding parts of the code to this general flow. Okay, so here is where we set the model into training mode. And after that, we loop through each epoch. Actually, this should be here. Yeah, but that should not bother with the performance of it. And we loop through each epoch, and we use something called PQDM to actually visualize the training progress. And that is what is being shown here. So TQDM is what handles like the visualization. So just something to keep in mind, so that you can just like keep track of the progress of your training process. So after, right, for each epoch, we load all of the images to the device, just loading it into the GPU or CPU. Then we zero out your existing gradient, so zero grad right here for the optimizer. And then we pass all of the images into the device. And then we just, sorry, not into the device. We pass the images into the model, and then we obtain its predictions right here, the outputs. Then using the outputs, we compare it with the masks or the ground truth predictions and determine your loss for that epoch. Okay. And then that loss, we just backward pass it, so back propagation, and then we update the weights. Okay. So we keep track of just the total loss of your model here. And then here, this is just for this line, it just tells TQDM to just display that. Okay. Now this line, it just I just use that for displaying the average loss during that epoch. And if I check that, just to just visualize it. And then after that, I actually start with the validation. So this was the training process for one epoch. Now I'm actually validating it. So I set it to evaluation mode, which is what you use when you're not training. And I just do the same thing again, but using the validation set. So exact same process. I zero out the the gradients. Actually, no gradients because we set it to no grad because we do not want the gradients to adjust during this validation process, right? We're just evaluating. We're not actually modifying the model a bit anymore here. We're just passing all of the outputs, and then we check the validation loss. And then after that, right here, this is the for adjusting the learning rate pala. But after this validation, I then compare it with the validation loss that the previous models have already obtained. And if I find like that the current validation loss in that epoch is less than the best validation loss previously, then I would save that as my best model right here using torch.save. Also, every epoch, I would save each model right here using checkpoint epoch. This name, this model name right here. So this just saves it into this checkpoints folder. Okay, so while we're waiting for that, we can actually move on to here, evaluation. So I'll just 7 minutes. This is actually going to take a long time, but eventually we're going to have a PTH file like this one. And I'll just stop this so that we can actually talk about evaluation. So, okay. Evaluation here. There are outputs. Okay. Evaluation. This refers to how we are going to like judge the performance of our model. In order to do that, I'm using two of the specified matrix that we talked about last, accuracy and intersection of reunion. So pixel accuracy, as discussed, it was used to examine like just the overall accuracy of a model. However, the limitations of pixel accuracy is that it doesn't take into account the structural shape of your predictions in comparison to your ground truth. So that is where intersection over union comes into play. Just shows you, okay, this is how good your predictions are in copying or having like similar structures to your prediction, to your ground truth. Okay. So this is how I compute each of those metrics right here. So what I do, I pass the predictions and the labels into this function. And I just say that this valid here is an integer, which just counts how many labels have been given like a valid class. So just in case somehow the prediction outputted like negative numbers or something, which shouldn't happen, but this is just like a safeguard. And then the number of correct pixels. So it computes like the number of correct pixels in here as those that are corresponding labels, the pixels which have corresponding labels to that of the prediction and the ground truth. So it just counts all of those and divides it to like the total number of pixels. Okay. So a similar way also here for IOU. So here I also count like for each class, I count how many predictions are also for that class as well. And then I compute like the intersection using just this this operator, this AND operator, and then this OR operator here. So just like overall, this is just how we compute intersection over union. Intersection and union, and then IOU, and then just compute for mean IOU right here. It's a very self-explanatory right here. So I just run those here in the evaluate function. I just set it again to eval mode. I'll perform the same things again with the validation set where I set it to no grad to not just the gradients. Then I forward pass the images, I get the predictions, and then I take the accuracy and the IOUs right here. And then I just compute for the mean for those. So let's actually try it out. I'll just run all of these again without running the training section. Okay. So I'll run this, evaluate, and then this function right here just loads the model from our checkpoint folder. This PTH right here. It's just going to load that in and use it. And finally, when you run evaluate here, it's going to start computing, and it should give us the mean accuracy, pixel accuracy, and the mean IOU here. So pixel accuracy here is 92.78%, and your IOU is 50.33. So it's it's not that good, honestly. But like the accuracy is good. So after seeing these results, we start to ask ourselves, why is it not good, right? And that's where visualization comes into play right here. So this visualization, this model, this function right here, all it does is that it's going to show me 5 sample images in the training dataset. And then after showing me the 5 sample images in the training dataset, it's going to show me the ground truth, and it's going to show me the prediction of the model. So that is all it's going to do here. Okay. So this is really good if you're also already working on research. Usually you're going to show this, show a diagram like this as well, in order to just for your writers to visualize like the effectiveness of your network and how it's actually predicting. So as we see here, what can we infer from all of these prediction images? So number one, the legends are here of all of the classes. And as we see, most of the images have people in it. So that is what the majority of our images here have, people. If we were to actually like run this again and have another random sample of the testing data set, it's more people again and again. And usually we only have few instances of the other classes like knives, cups, spoons. So they are very sparse in our data set. And that might be why we are having a really low intersection of reunion, because we do not have enough data of these other objects and classes in our data set, that our model is not actually learning them enough. It needs more samples of these informations, of these images. Right? So that's how I would interpret this as, because like it's really good at seeing the people, but like when differentiating it from others, it may need more training for that. See? So this is the ground truth, this is the prediction. This is what our model is giving. So right, it doesn't really necessarily see that it's a chair, but like it's getting there, you know. And for knives and forks and spoons, not at all, because they only show up in our data set sometimes. So we need more data for that. Okay. So that is all for like the notebook part of the session, but like I would like to leave you guys with something that you can also use here. So I have this also just like an additional script that you can use called webcam.py. So it does what you think it does. It runs the model inside your webcam. I just can't load it right now because why can I not load it? First, I have to go back here. And I think I need to turn off my webcam for this. Or would it work? Yeah. But this just also does the same thing that we're doing. But just, yeah, okay. I have to turn off my webcam for this. So let me just try that out. Okay. While this is loading, this just uses OpenCV in order to just access your webcam and then run the model from there. So there, I'm now showing like a different instance of my webcam right here. And now it's actually running the model. Okay. So as you can see, it's like really good at detecting people because that is what the program was trained on. However, if I have a spoon here, I don't think it's actually going to. Yeah, it's not actually trying. It's like it's getting there, but like not enough information. Okay. So I'll just turn this off. We'll send all of these workshop notes as well after the actual meeting. And that concludes the entirety of our workshop for today. So thank you for listening. And if you guys have any questions, please feel free to like give them now. Thank you.
Okay, thank you for the presentation, Aaron. The floor is now open for questions that you might have. Since maybe we can take 1 to 2 questions, but the more questions, the better. Actually, my question that I have written here in my notes, nasagot na ni Aaron, no? Because towards the end, he also visualized the results aside from just showing you the numbers. So usually kasi, when you report numbers, no, there are two numbers that Aaron reported earlier, and it seems like it's showing you different signals, no? One is telling us the accuracy is good or the pixel accuracy is good, while the mean IOU parang may kaunting problem, no? Not really a problem, but at least in showing all of these metrics, no, it will tell us something about how our model performs. If you're just using one, most of the time it does not show you the complete picture, but you're using two here and you can actually use more depending on your use case. Whether this is better to report or this is better to report, again, it would be based on the use case that you have. But usually, and I tell this as early as CS model to my students, you have to, aside from just reporting the numbers, you have to report the visuals because the visuals will tell you something else about the data. Okay? So that's basically for my students, our lab students in this call, especially those doing their thesis 1 this term. Yung mga nasa thesis 3, they already know that they need the numbers and the visuals always. No, showing the visuals and the numbers. But for those doing their thesis proposal and those who will do their thesis proposal in the future, towards the end of your thesis, you'll be required to show us the numbers, no? And at the same time, show us visualizations. Maybe as early as the proposal, we might need to ask you that kasi that gives us a context of how your model performs. Okay? So, that's actually my question, but it was answered towards the end of the presentation. And also Aaron was showed us and explained the various parts of the code properly, especially on um, how to train the model, how to evaluate what is yung sa grad, no? All of those special information that we know when we're training our model. So could you please raise your hand if you have no questions? We're going to give you all of the recording as well. It will be posted in YouTube and the notebook that you could use for as a reference for the workshop. We are also going to provide that to you. Okay. So I think no questions from anyone. Thank you, everyone, for attending our workshop. I would also like to thank Aaron for presenting this topic. No? So if there are no more questions, I guess that ends our workshop for today. Hopefully we are going to see you in, I think, 3 weeks. We have another set of lectures, if I'm not mistaken, in 3 weeks or 2 weeks, but that would be on a Saturday. So hopefully you could join us for that event, for that lecture. We're going to have a series of 3 different lectures on 3 different topics. We have already posted the information about this one in our Facebook page.